All right, so now we have made it to our statistics and our probability sections. So with this, they're called this exploratory data. This part here, we're talking about types of sampling, because 27 says at the very bottom, at the very end of it, this is an example of sampling what? So our thing is, a bank wishes to survey its customers. The decision is made to randomly pick 10 customers who just have banking accounts, 10 who have savings accounts, and 10 who have both. They have a banking account, other types of accounts, and then a savings account. So if we're looking at this part, what type of sampling is it? So we talked about multiple different types of samplings where we actually did we counted every 10 people, or we did clusters. We clustered people and then pulled random people out of that, a certain amount of people out of each one of them. We talked about so many different ones. But the one that we're looking for in this type, when it comes to our sampling, so if you go back to the sampling note, you'll see what we're talking about. The one we're talking about right now is not that one, it's this one, the stratified sampling. Stratified sampling is when a population is divided into groups with similar characteristics, and a sample is randomly chosen from each group. And pretty much, if you look back at what we just talked about there, pull it over a little bit. There we go. There we go. All right, so it says again, decision is made to randomly pick 10 customers who have banking accounts. So we have just a random group of population there of people that have bank accounts. And then there's 10 savings accounts, and then there's 10 that have both. So they divided the population or the group into two different groups, one with just savings accounts and one that has probably like a checking account and a savings account, right? And then they say they are going to choose at random. They're going to make a decision, randomly pick them, just 10 out of it. So out of both of these, we're going to pick 10. So randomly choosing them. So this one is divided into different groups, and then we're just going to randomly choose from out of that. Stratified sampling. There we go. Stratified sampling. Number 27. All right. Now, when it comes to 28, let me write this down first. This way, for people that have that need the hard copy, I'll have this for you. All right, for 28, it says, can changing diet reduce blood pressure? I wonder. All right. So with that, it says vegetarian and low salt diets are both promising. So it's like, wait a minute, these are kind of like, we're talking about experiments here, because like they're talking about promising, we're going to actually try stuff on people. So maybe we're going to talk about our experimental notes part, the designing experimental notes type thing. Maybe that's what it is. Maybe we should go look at that one. Yeah. It's going to be an experiment here. So men with high blood pressure are assigned at random to 4 diets. There's the normal diet. There's the vegetarian with unrestricted salt. There's normal with restricted salt. There's vegetarian and vegetarian with restricted salt. So there's 240 subjects, and we're going to be labeled between 0 to 001 to 240. And then the software is going to just randomly assign 60 subjects to each of the 4 diets. It says diets. So this is an example of what? So we already talked about, okay, this is an experiment because we're experimenting to see which one of these diets works best. So we know it's an experiment, but we have to figure out which type is it. So if we go through all of our list of experiments that we had in our notes, we'll see that our completely randomized design is actually what we're talking about here. And what does the completely randomized design mean? It means that all experimental units are allocated at random among all treatments. So if you look at it, there's 4 different treatments that are happening, 4 different diets. Those are considered treatments to try to help the blood pressure treatments. There's 4 different treatments. There's 240. and they say they're going to randomly allocate all of these these men into these 4 diets. So they're going to randomly put them in these 4 diets. So they completely randomized everything because they don't know who's going where. They're just going to put them in there. They're just going to choose it, and they randomly allocate all the people in the units, experimental units, which are our subjects, in here. And again, here, just terminology really quick. Subjects, we talked about that, was another word for experimental units. We said experimental units, if they are humans, they are called subjects. So that's our experimental units are these people, these men, these subjects, and they're being allocated into different treatments programs. So therefore, completely randomized design. Woo! We got it. Yes. All right. So let's move into our last 2 questions, guys. And let me write this down too. I'm writing down the answer again for the hard copy for those that need to have that hard copy. So that's all I'm doing here. All right, so now let's go to 29. Woo! 29. It's probability now. So we did our statistical portion there, just a little bit of it. And then now we're going to come here and deal with our probability portion. All right, so 29. So it says a standard number cube is rolled and a card is drawn from a deck of 10 cards, numbered 1 through 10. So that's what it says there. Oh, it says 10 over here. 1 to 10. So it says find the probability of odd on the number cube and less than 7 on the card. Okay, so we're going to do with all of that. So we're going to deal with the probability of it being odd for the cube, an odd number on the cube, and going to be less than 7 on the cards. All right, so we're going to take a look at this. We're going to look at what they give us and all that great stuff and flow through this bad boy and get it done. All right, so first off, we know when it comes to a die, there's 6 like sides to it. So our sample space for our die, or sorry, let's say cube. If you do a cube, there's only 6 sides on the cube too. So our sample space is 6. All right, so if you look at a cube and it's numbered, we do 1, 2, 3, 4, 5, 6 because there's only 6 sides. There's only 3 odd numbers on there. Only 3 odd numbers. And that talking about standard, so there's only 3 of them. 3 odd numbers, 1 through 6. So 1, 3, 5 are your odd numbers. All right, and then the cards, they say, okay, there are 10 cards in all. Our sample space would be 10 then. That's our 10 cards. All right, and then it says the cards that are less than 7. If you think about them, okay, if we're going 1 through 10, and we say, okay, how many cards are less than 7? That means 1 is less than, 2, 3, 4, 5, 6 are all less than 7. 7 is actually equal to 7, so it's not less than. So there's 6 cards that are less than 7. So 6 cards that are less than 7. All right. So at this point, we're going to go ahead and deal with our probability over here. And because we're talking about and, remember, and just deals with multiplication. So when we do with this, we're going to deal with multiplication. So here, our odd cube, that'll be 3 out of 6. So 3 out of our 6 in all. Times, because and means times, multiply. 7 cards are less than 7. There's 6 of them that are less than 7 out of the 10. All right, we're going to multiply those. We get 18 over 60. That reduces down to 3 over 10, which you can say that's 0.3, or you can say it's 30%. So I'll take any of those. Those are all considered numbers or answers for a probability. So I'll take all three of them. So the fraction there, simplified fraction, the decimal, or the percent. Easy, guys. Easy. We got this. Woo! So how we're going to do well. We're going to get this. We got this. This final exam, we're going to blow out the water. We're going to make hundreds. Yes, sir. Yes, sir. I'm excited to see all those hundreds coming up, too. All right. And so the last one, question 30. Oh, my gosh, you made it to the end, guys. Dun, 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 dun. Boom. We made it to the end, guys. We made it. All right. So this last one says, you pick a card from a deck. Just one card. Just a card from the deck. If you get a face card, you win $5. If you get an ace, you win $30. Plus an extra $60 if you get an ace of hearts, though. So if you get an ace, you get $30. But if you get an ace of heart, it's $30 plus that $60 right there. So, all right. So then we're gonna find then any other card that you get nothing. You don't get nothing for that. So our goal here is to find what is the expected value that I will win for playing this game. So what would it be? Will I gain money? Will I lose money? Will it be positive, negative? Will it be fair, not fair? Remember we said if it's positive, it's a good game. It's a fair game. If it's zero, it's a fair game. If it's positive, that means it's a good game for me to win. It's an advantage. If it's a negative, it's a disadvantage. Don't play it because you're gonna lose money. All right. So here, if you remember back to our expected value notes, again, this came up this year right before Thanksgiving. So if you're a part of the 2020 fall semester, you had it right before Thanksgiving. But if you're not part of that one, then it's okay. All right. So here, if you remember back when we did our expected value, and I'm giving you 4 because there's 4 different things happening. There's the face cards, there's the aces with the heart, and then there's the other ones. So we said there's an outcome here. We have the probability. There is the value, so the amount of money or whatever. And then we have our total. So I'm going to put that space for value because I need a little bit more space on that one. That's why I made it like this. You can do it with 4 if you need to, but I just needed extra space for this. Probably need extra space for the total too, but it's okay. It's okay. It's okay. All right. So for the outcomes, we have a face card. We have an ace. We have the ace of heart. Oh, I made a little heart right there. I made a little heart. And then we have the other. All right, so we have face, ace with the heart, and then the other. All right, so looking at this, the face cards, there's 4 suits, and we talked about this when we did our probability of addition and multiplication. There are 4 suits in a deck of cards. Out of those 4 suits, there are 3 faces in each suit. Oh, you can't see it, sorry. There are 4 suits, and let me actually make this big for everybody. There we go. All right, so there's 4 suits there. There's 3 faces. So here, that means in all, there are 12 faces in a deck. Face cards in a deck. All right, and then also just a quick reminder, for our sample space for all of these, there's 52 cards in the deck. Oop, not space, sample space. Sorry, guys. There's 52 cards in all. All right, so there's 52 cards in all. That's our bottom number. 12 will be our top number. So probability is 12 out of 52. All right, when it comes to our aces, since there's 4 suits, there's 4 aces in all. But here we're breaking them up to be the other aces and then the ace of heart. So we're going to say there's three aces here.